am a visionary, exploring a universe of data to sharpen our view of the most distant galaxies, and studying black holes to help prove Einstein's theory of gravitational waves. I am a healer, giving doctors the power to turn mountains of data into life-saving breakthroughs, identifying lung cancer earlier and with fewer false positives, and finding new ways to bring cures to market faster. I am a helper, empowering the disabled in their homes and breaking down barriers.
She's so beautiful. Who is she?
Across languages
她真漂亮，她是谁？
and generations. I am a protector, keeping our data safe from cyber criminals and helping the lost find their way home. I am a navigator, mapping our world 1 millimeter at a time, and making even the largest self-driving vehicles safer for the long haul. I am a teacher, analyzing 500,000 player moves every game to identify strengths and weaknesses, and a learner, discovering new strategies from complex games. I am a creator, learning to paint from the masters and applying their styles to create original works of art. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Ladies and gentlemen, please welcome NVIDIA founder and CEO Jensen Huang. 各位来宾，请欢迎英伟达创始人兼 CEO 黄仁勋先生。
Hello, Beijing! 大家好。Welcome to NVIDIA GTC Conference 2017 Beijing. It's great to be here. This is NVIDIA's GPU Computing Developers Conference, and we have a lot to share with you today, so let's get started. In no time in our computer history has such exciting developments have been happening and such incredible forces in computing that's affecting our future. There are two fundamental forces that is affecting and driving the future of computing. First, the end of Moore's Law. The pace of technology for the last 50 years has steadily and reliably improved. But over the course of the last several years, it is now impossible to continue to scale transistors, semiconductor process, at a rate that allows us to increase the number of transistors, make the transistor faster, while keeping power density constant. It is now too difficult to continue to shrink transistors down to the atomic levels. Meanwhile, those transistors, over the course of the last 3 decades, were applied to improve CPU architectures, widening the pipeline, widening the data path, making the pipelines deeper, adding architectural innovations like superscalar technology, out-of-order execution. Those transistors, as the process technology afforded more and more, made it possible for CPU designers to extract more instruction-level parallelism out of applications. Both of those forces, both of those dynamics have ended. It is now more and more difficult to shrink transistors, and CPU designers are no longer able to apply those increased number of transistors to better use, to extract more performance from CPUs. As a result, process technology continues to afford us 50% more transistors every year. However, CPU performance has only been increasing by about 10%, the end of Moore's Law. Simultaneously, at the same time, we're seeing a new computing model emerge into the world. This model of computing called deep learning has caught the world by storm. This new computing model is not an instruction-focused computing model, but a data-centric computing model. A neural net, a very, very large and very deep neural network with hundreds of millions of connections, learn from data to perform amazing tasks. This neural network called deep learning, combined with big data, made it possible for new breakthroughs to happen. However, it needs an enormous amount of computing horsepower. And that is exactly the reason why the GPU emerged. After investing in CUDA for almost 15 years, deep learning researchers discovered the power of GPUs to accelerate the development and the training and the processing of big data on these deep neural networks. These two fundamental forces are now foundational to the future of computing. We have to, on the one hand, find a new computing model that allows us to continue to scale with more and more transistors, delivering performance with every generation, because we need it desperately for a new computing model that is so revolutionary called deep learning. This is the reason for the rise of the NVIDIA GPU computing model. It is because we can translate more transistors every single generation to productive performance, energy-efficient productive performance. We can continue to scale with the transistors that come along with each process generation. And because of the enormous computational capability of our GPUs, we could apply that capability to accelerate the training, the development of artificial intelligence, making it possible for researchers to train these deep neural networks that would have otherwise taken a month in just one day. And that has kick-started the deep learning revolution. This is the world we're in today. Incredibly, incredibly exciting. Now, GPU computing has been embraced by hundreds of thousands of people. In fact, in just the last 5 years, GPU attendance, GTC attendance has grown to 22,000 attendees this year. Thank you very much. There are 615,000 CUDA developers in the world. 615,000. Just 5 years ago, there were 14 times less. And now this year, 800,000 new downloads of CUDA SDK was downloaded, and making it, in the last 5 years, grown 5 times. The progress of GPU computing is really remarkable. Well, the driving force behind the GPU, of course, the first killer app was computer graphics. And it has been the dream of computer graphics engineers to create the virtual reality environment where everything is possible. Building anything is possible, experiencing anything is possible. It is photorealistic, it behaves according to the laws of physics, and it makes it possible for us to share that experience from wherever we are. We've been building this holodeck for some time, and we call it the NVIDIA Holodeck. And to show it to you, I've got some friends. Hey, guys.
Hey, guys.
Hi, guys.
Hi, Jason. Jason.
Okay,
Welcome
so
to Project Holodeck.
thank you. Sean, which one is Sean? Sean, and
I'm right here.
searching. Which one are you? And
Hey,
Roy.
Jason.
And you guys are
Hi,
standing in
Jason.
front of a beautiful car. By the way, this is the Koenigsegg, and I had a Koenigsegg, And this is just an amazing car. And Christian Koenigsegg, the creator of this car, was generous to share with us the entire design database of this amazing car. And so, Sean, tell us what you're going to show us.
So we've loaded here into Holodeck so that we can explore it in some other environments.
Everything is being computer generated. Everything is in real time. Notice the beautiful car paint, the rubber of the tires, the carbon fiber wheels. Completely photorealistic. Look at that. It's just absolutely amazing. Isn't that beautiful? They are right now inside that virtual environment. The world's best computer graphics.
So we can explore different car paints and materials and really jump inside of the design. But hey, let's check out some of the physics of this environment as well. Roy, could you open the door for me?
Sure.
Wow. Look at that glass, the reflection on the glass. Keep on going, guys.
As a collaboration tool, we can use Holodeck to explore the design with different tools. Searching just handed me the clipping tool so I can cut in through the geometry to take a look at this door hinge, which enables the door to open in such a small amount of space.
Now, you guys know that the Koenigsegg, you might have seen this, where the door, it doesn't flip open like a gull wing. It doesn't open like a normal door. The door pivots slightly, and it flips open vertically. It's just absolutely a remarkable feat of engineering. Look at that. Isn't that amazing? And so with a virtual reality environment like the Holodeck, we could see things perfectly photorealistically, the original design, and we can share that experience with our colleagues wherever they are. You could have a colleague here in Beijing, somebody in Silicon Valley, and together we could be working within this entire environment at the same time. Okay, Sean, what else you got?
So as you mentioned, the entire CAD design is in this here. So we can take a look at all of the parts.
Wow.
So each of the 20,000 components is featured here.
What an amazing way to design a product. We imagine that someday, we would design products inside virtual reality. We would create the factory that would make this product and allow virtual reality and artificial intelligence to work together so that these robotic factories would be completely designed in virtual reality as well. So the factory becomes a robot, the robot builds the product that you designed, and all of it is done in virtual reality. That's amazing, Sean. Do you have anything else?
That's it.
Okay, guys, thank you very much.
Thank
the
you.
NVIDIA Holodeck.
Thank you. Thank you. Goodbye. Bye.
NVIDIA Holodeck, photorealistic models, physically simulated interactions, virtual team collaboration. We could be anywhere in the world, collectively collaborating together in one virtual reality environment, and all of it also includes artificial intelligence. Let me now talk about artificial intelligence. Whereas computer graphics was the first killer app of GPUs, artificial intelligence and deep learning is the new killer app of GPUs. If you take a look at what's happening in artificial intelligence over the last several years, amazing progress and incredible momentum behind this new technology that was made possible by GPU computing. There are now 12 times as many startups than 5 years ago. $6.5 billion have been invested in AI startups this year alone. The rate of progress of invention and discovery is accelerating. In fact, 3,000 papers were published this year alone in the field of deep learning and artificial intelligence, a growth of 13 times in just the last 3 years. This is truly amazing. The number of great researchers and computer scientists that are focusing on deep learning is staggering. And then lastly, look at this chart. NIPS is one of the world's leading conferences for artificial intelligence. Neural information processing systems. It's really about neural net processing. This has become the mecca where artificial intelligence researchers go. This chart shows you the registration rate of people attending NIPS. In the last several years, you could see that people don't start registering until the day of the conference practically. However, the registration of NIPS this year skyrocketed to all-time highs because everybody wants to make sure that they can have secured their place in that conference. This is just a great indication of the enormous interest in deep learning, the enormous interest in artificial intelligence. Well, the progress that's been made is really quite amazing. Artificial intelligence has made it possible for us to solve the unsolvable problems, to solve the previously unsolvable problems. And you could see there's just some amazing advances. Let me show you some of the funnest ones. This first one is called ray tracing. Ray tracing is a form of computer graphics that is highly computationally intensive, and even on the fastest computers take a very long time. Ray tracing, until now, has never been interactive. By applying artificial intelligence, the researchers at NVIDIA were able to complete a partially completed image. This is ray tracing, where each one of the rays is a ray of light as we follow that ray of light throughout the room. Notice how quickly artificial intelligence was able to complete that picture. Using artificial intelligence, the neural network was able to predict what is the most likely color of the uncompleted pixels. Notice how quickly it fills it in. The next one is amazing. The next one is a neural net that learned how to talk, how to animate a 3D character. This is also done by a team at NVIDIA and a team at Remedy.
Listen up. The train yard warehouses is our main objective. Alexei,
in this particular
you
example,
and your men will do that.
the neural net watched videos of a person talking and learned how to animate its three-dimensional character face by listening to the audio. And now we can input audio, and the output would be an animated face. Animated character. This next one is amazing. It's possible for cameras, just by watching us, to figure out our pose. Our pose is how our body is configured in three-dimensional space. By watching a two-dimensional video, we can now estimate your three-dimensional pose. The power of this technology is a virtual reality environment. So you imagine the first example of the holodeck. The next time I see you, it is very likely that I can go into that environment myself. Just with a camera, pose estimation, artificial intelligence, I can go into these virtual worlds. This is done by Wrench, a really fantastic company in Canada. This next piece of work is done by University of Edinburgh, and this is a character animation artificial intelligence. And what's happening is, independent of the terrain that you put in front of this character will figure out how best to navigate that different terrain. You could put a rock in front of it, stairs in front of it, a wall in front of it, and this character has learned how to traverse these different terrains. It's so incredibly humanistic. Imagine all of this in virtual reality. And this next one is really fantastic. This is a robot that was taught with a technology approach called one-shot learning. One-shot learning. The researchers went into virtual reality, and with just a few examples of stacking cubes, this robot was able to learn by itself how to stack cubes. One-shot learning. Incredible. All of this technology is made possible as a result of deep learning. And that's why I say that artificial intelligence powered by deep learning is now able to help us solve the unsolvable problems. Our contribution, and we're incredibly proud to be the platform by which researchers all over the world is able to advance their AI. We dedicated ourselves to one singular architecture. And the reason for that is simply because architecture allows us to create a software platform by which the entire world can build all of their innovations upon. We have to stay dedicated to this singular architecture, advance it with the entire might of our company, The scale, the level of investment, the velocity of engineering allows us to create a stable platform that's continuously advancing over time. We also make it possible to enjoy our platform in all kinds of sizes and shapes, whether it's in supercomputing centers, inside a PC with GeForce Titan X, in the cloud, or even in little tiny computers that you can place inside robots. The NVIDIA AI computing platform is used by researchers all over the world, applications of all kinds. We're incredibly proud of this, and this is an area that will continue to advance. Today, I'm excited to announce that China's top CSPs, Alibaba, Baidu, and Tencent, 3 companies with enormous investments in artificial intelligence, with extraordinary capabilities in deep learning. The researchers of these 3 companies and us have been working together for some time. Today, they announced that they will adopt NVIDIA's AI computing platform based on our latest generation technology, the Tesla Volta, for their internal development of artificial intelligence, as well as the public cloud, so that researchers and startup companies all over China could have the benefit of the world's most advanced AI computing infrastructure without having to invest in their own data centers. This is just an incredible announcement. I'm really happy to welcome them to the NVIDIA AI computing platform. Thank you. There are companies out in the world, in China, who simply can't use the cloud yet. And the reason for that is because they need to have control over their own AI infrastructure. They have too much data. Maybe there are privacy concerns. Maybe there are security concerns. And they would like to have access to their own dedicated AI infrastructure. For them, today we're announcing that China's leading enterprise IT companies, Huawei, Inspur, and Lenovo, has also adopted NVIDIA's AI computing platform and will be taking our HGX-based servers all over China. Thank you. With this partnership, we could take the AI computing platform to industries from transportation, healthcare, financial services, industries that can benefit from artificial intelligence. I'm super excited about this. Thank you very much. Our vision at NVIDIA is to build the foundational platform, the AI computing platform, for the world's AI researchers to advance AI. We support every framework. Because it's a programmable platform based on CUDA, we're able to integrate, optimize, collaborate with framework engineers all over the world. As a result, every single framework is optimized for NVIDIA's platform, whether it's on one GPU or scalable to multiple nodes and, in the future, thousands of GPUs. Every single framework, from Caffe 2 to Chainer to Microsoft CNDK, MXNet, PyTorch, TensorFlow, Theano, and here in China, we've partnered with Baidu to optimize the NVIDIA platform with their Paddle AI framework. Our platform is available from every cloud. It's available from every leading system maker. And as a result, this platform is available for every researcher and every startup company all over the world. NVIDIA has a platform called Inception. It's a program that allows us to collaborate closely with startups, support their endeavor, advance their work together, and hopefully create the next generation great companies. The NVIDIA Inception program has 1,900 deep learning startups in it. 1,900 deep learning startups. 300 of them here in China. And they cover all fields of industries, from transportation to healthcare to financial services, internet services, consumer services, drones, manufacturing robots, so many different fields, so many industries are going to be revolutionized by AI. Thank you for all of your support. So that's the development, that's the advancement of AI. That's about developing a computing platform that is so powerful that it's now possible to train these complex networks of deep learning. Once the network is created, the next great challenge is inferencing. Developing the networks, training the networks on NVIDIA's GPU computing platform, on all of these different frameworks, creates a computational graph. This computational graph, a neural net, is intensely complicated. Hundreds of millions of parameters, computing graph of great complexity, allowing it to recognize images, recognize text, recognize speech, translate languages, and do all of the amazing things that I showed you just a second ago. These networks are going to run on all kinds of devices. Artificial intelligence is the future of computing, and it's going to make it possible for us to infuse intelligence into all kinds of services and software applications and devices and computers of all sizes and shapes. We're going to be able to make all kinds of new types of products and reimagine many of the existing products in the world. Running that network on these computers is called inferencing. Inferencing, to infer from the inputs some knowledge, some insight about the circumstance. Okay? Inferencing. These networks are incredibly complex. In fact, if you look at the original CNN, the AlexNet is one of these classes. It's a convolution neural network. I think it was originally 8 layers, and it has the ability to recognize images better than all of the computer vision algorithms that have been developed before that. And today, if you look at the number of architectures of networks, CNNs are getting deeper, they're getting more complex, the layers are being re-engineered so that we can continue to advance the precision and the capability of these convolution neural networks. We also have the emergence of recurrent neural networks with long-term, short-term memory, long short-term memories that allows us to recognize sequential patterns, long sequential patterns. For example, voice recognition, translation of languages. In fact, voice recognition and translation of languages has now achieved superhuman levels as a result of the progress of LSTM. And we have this amazing new network architecture called the generative adversarial network. It's a neural network where one network is designed to detect, where another network is designed to generate examples to fool the detector. That's why it's called adversarial. 2 networks competing against each other. Eventually, trained with so many examples and so many iterations, the generation network is able to now create images or sounds and create examples that are very much like the original. Really, really quite amazing. And then lastly, reinforcement learning using trial and error. Trial and error, these networks are rewarded or punished based on a value function. Just like the way we learn to play something and perform a particular task, we use trial and error to learn. And so the robots could learn how to behave like robots based on reinforcement learning. All of these networks are being architected and created so that we can bring more and more capabilities into artificial intelligence. The technology is really advancing incredibly fast. In fact, I don't know if you guys noticed some of the networks. Did you guys notice that? They resemble technology from outer space. So for Star Wars fans, I think you'd enjoy that. explosion of network designs, and it's not slowing down. 3,000 new papers created more examples of neural nets in the future, and we're going to see many, many more to come. The complexity of the networks is also exploding. On image recognition, and the complexity is exploding and growing in two different scales. The amount of computation necessary and the amount of memory that's necessary to support it. On the one hand, it's billions of operations per second. On the other hand, it's megabytes per second as it accesses a very large memory. Both of these parameters are growing simultaneously. As a result, when you take the product of the two, if you look at AlexNet, that little tiny dot in 2012, the revolution started with AlexNet, a network that was able to achieve superhuman levels of computer vision algorithms, beating all of the previous computer algorithms before it. And now, if you take a look at the latest generation CNN, Inception v4, 350 times more complex in just 5 years' time. 350 times more complex. This is just so that we could achieve greater and greater levels of accuracy. Speech recognition has also gone through the same explosive growth. In just 3 years' time, a speech network has achieved superhuman levels of speech recognition, and now 30 times more complex than just 3 years ago. Translation. It is still my dream that someday I will speak in English, but it will come out in Chinese on the microphone. And I believe that dream will happen soon. In fact, I'm certain of it. At least it will save me to have to do that for you last night. Translation networks has also grown incredibly. From OpenMT to MOE, the nature of these translation networks has grown. The complexity has grown by a factor of 10 in just a couple of years. What technology increases in complexity by a factor of 350 in 5 years? We don't know any. What algorithm increases in complexity by a factor of 10 in just 2? We don't know any. We are moving at faster than Moore's law. GPU computing advance is moving at faster than Moore's law. Neural network complexity is advancing at faster than Moore's law. These two exponentials, GPU computing exponential, neural net complexity exponential, when you combine the two, this is the reason why we are going through one of the most revolutionary times in all of computing. Moore's law was yesterday's law. It is the slow law. We are now in super real-time law, super Moore's law. This new time, advances are going to happen at incredible rates, which explains why so many world-leading companies in computer science are racing to embrace, are just utterly racing to embrace artificial intelligence and deep learning. There's one other reason. The application of deep learning is going to reimagine, it will transform industry after industry after industry. In the near future, you will see these neural networks that have been trained will be deployed to improve and enhance and add magic to internet services. There are 20 million servers in the cloud. Every single one of them will become inferencing servers. Every single server in the cloud will become an AI inferencing server. There will be hundreds of millions of autonomous machines. There are something like 2 billion cars on the road today. The single most important revolution in the transportation industry is happening right in front of us right now. The combination of electric energy, electrical cars, and artificial intelligence enabling autonomous driving is coming together at exactly the same time, and it will revolutionize the transportation industry. Those 2 billion cars will be replaced by autonomous vehicles that are electric. We're going to see, in fact, the same technology of autonomous machines will also revolutionize robotics, delivery of the last mile, intelligent drones that navigates by itself. And then lastly, every single sensor, every single little device in the future will have an artificial intelligence network inside. Maybe it's just a little tiny watch that's measuring your heartbeat just to make sure that your blood pressure is good. Maybe it's measuring temperature, pressure, vibrations to detect early warnings of machinery that needs to be replaced. Trillions of sensors will all be infused with artificial intelligence networks. This is the future of the computer industry. Internet services that are just utterly magically intelligent. Autonomous machines that are interacting with us and moving through society autonomously and safely. And every single sensor, from a microphone to a thermostat to a camera to vibration sensors, all will be infused with artificial intelligence. The explosion of intelligent machines. And so that's one of the reasons, that's the reason why it is so vital now for us to shift our attention to solve the next gigantic challenge, which is inferencing. Inferencing of all of these incredible number of networks that are evolving in architecture, inferencing for these networks that are exploding in technology capability, computational capability, and inferencing as we need to scale from supercomputing levels, all the way down to few milliwatts. We need to be able to support a very wide range of computing. Artificial intelligence will revolutionize every aspect of computing that we know. And so it is with great pleasure today that I'm announcing a brand new initiative in our company. We've been working on this challenge for several years. And today, I'm pleased to announce the NVIDIA Tensor RT 3, the third generation. Tensor RT is a programmable inference accelerator. It's an optimizing compiler for neural networks. This software framework takes the computational graph that comes from any framework. It could be TensorFlow, it could be Caffe2, it could be Chainer, it could be PaddlePaddle, it could be PyTorch, Theano. We would take the computational graph, which is a very complex program, and compile it and optimize it for the target CUDA architecture. So on the left, on the right, on your left, we have the frameworks, which generates the computational graph. We ingest the computational graph, and we create an optimized runtime targeted at all of the different platforms that NVIDIA has, with different capabilities, different power levels, different performance levels, and different use cases. Inside Tensor RT, which is an optimizing compiler, we optimize for many things. The first thing that we optimize for is to recognize the architecture that we're targeting. What are the instructions that it has? What are the precision capabilities that it has? We understand the target device. We calibrate all of the precision, and then we optimized through the graph. Maybe we optimize the layers and we fuse them together. Maybe we optimize the kernels. Maybe we optimize the tensors and we fuse some, and maybe even some could be eliminated. We optimize the graph. The next thing we do is to understand that each one of these kernels could be accelerated using our processors to recognize how best to program that kernel. So kernel optimization and dynamic tuning across this entire graph is extraordinarily complex. And then lastly, to recognize that we have multiple streams of operations that are happening at the same time. Maybe this is a GPU that's in the data center, and billions of queries are coming into the data center, and we want to optimize its throughput with the lowest amounts of energy at all times. Tensor RT is an extraordinarily complicated optimizing compiler. Tensor RT on our latest generation Volta delivered amazing results. Let me show it to you. This is the performance. So on the blue is CPU running TensorFlow. So you train your network with whatever you train with NVIDIA's GPU. It creates a computational graph. That computational graph then runs on a CPU is that blue line. In the case of Resonant 50, a CPU can compute 140 images per second. Remember, this neural net program is highly computationally intensive based on what I showed you previously. A V100, a Volta, with an uncompiled, unoptimized computational graph right out of TensorFlow can deliver 300 frames per second. But this is where the magic happens. Because our architecture is unique. A GPU architecture is complex. Its capabilities, although enormous, requires a specialized type of compiler. That's the reason why we created CUDA, that's the reason why we created cuDNN, and that's the reason why we created Tensor RT. Tensor RT allows us to target all of the capabilities of Volta and to take advantage of it for the computational graph that comes out of the framework. And with it, 5,700 images per second. In the case of language translation, a CPU can translate 4 sentences per second. This is the output of open natural NMT, natural machine translation, basically a language translator. It can translate about 4 sentences per second. In the case of Volta, right out of Torch, we can translate 25. And then once we optimize it with Tensor RT, 550 sentences per second. But that's just one side of the coin. That's just one of the pictures of thinking about the throughput and the performance of these neural networks. We also have to recognize that the latency of computation is equally important. And the reason for that is because it has everything to do with the quality of service. When you talk to your phone, when you search for something, you would like the response to be instantaneous. If it's instantaneous, the latency of response, the faster it is, the more you would enjoy the service, the more likely you will click, the more likely there will be an advertisement that could be offered to you. So these internet service providers, these cloud computing companies, are highly incentivized to make sure that the quality of service is excellent. And so latency is vitally important. In the case of CPUs, 14 milliseconds. In the case of V100, 7 milliseconds. But this is the one that's really dramatic. Voice recognition, natural language translation, understanding, all of that technology will highly relate, and the quality of service will relate to the latency that we enjoy. In the case of a CPU, about 280 milliseconds. In the case of V100 with Tensor RT, 117 milliseconds, all the while processing 550 sentences per second. What do you guys think? "40 times speed up on images, 140 times speed up on translation, and half the latency, twice the quality of service. Nearly 100 times the throughput, twice the quality of service." It is just too good to be true. Now, when you translate all of this to a data center, it translates directly to TCO, total cost of ownership. This is what 100 servers looks like, 160 servers look like. These 160 dual CPU servers will probably cost something along the lines of $600,000 or $700,000 with all the networking and the top of rack and all the power delivery, so on and so forth. These 4 racks of 160 CPU servers, 4 racks, 160 CPU servers, will throughput 45,000 images per second and consume 65,000 watts, 65 kilowatts. If we were to apply the Tesla Volta with optimizations from Tensor RT, this is what it looks like. Before, after. I love this. Before, after. I could sit here and do this all day long. All right, just one more time. Who doesn't love that? Who doesn't love that? Increased throughput, better quality of service, less carbon footprint, less space. And this is the part that I love the most. Save money. Even my mother loves this. She doesn't buy any servers. She says, "Son, save money." Every day I save money. So I tell my mother I save money. Save money. So 4 racks in just one box. 4 racks in one box. That's the benefit of programmable inference acceleration. The benefit of programmable inference acceleration. So many different types of networks. There is no way to build one custom chip. So many different framework outputs. All the formats are different. The complexity of the networks are growing every day. And so that architecture must be able to support these enormously large networks. By definition, because the NVIDIA architecture was used to create the networks in the first place, it stands to reason we should also be incredibly good at inferencing. We just need to create new instructions for inferencing. We have to create new software tools and new infrastructure necessary for accelerating inferencing. And if we do that, we will improve throughput by 140 times. We will reduce cost tremendously. Now, we're going to show you a demo. This is really fun. This is what it looks like when you're inferencing. So these are just a whole bunch of flowers. I have a friend in the back. His name is Ryan, and he's created this demo for us. And so the first thing that I'm going to show you is CPUs doing inferencing of these flowers. Now, before we show you the demo, the thing to realize is this. This network was created from TensorFlow, and it uses ResNet 152. It's a very complex network, 152 layers, ResNet 152, and it was trained by TensorFlow. The output of that computational graph has the ability to recognize flowers. So the first part is this. It's amazing how good artificial intelligence is at recognizing flowers, fruits, animals, almost anything you put in front of an artificial network today, it could recognize much, much better than you. So the first thing that I noticed is how few flowers I know. And how good this artificial intelligence network is. And then the second thing we'll show you is how fast it would be if it was optimized by Tensor RT. So Ryan, why don't we take a look at the demo?
Okay.
Okay, so this is our demo. This is the CPU. It's inferencing, it's recognizing the flowers one at a time. Each one of the flowers takes about 250 milliseconds. 250 milliseconds. 1/4 of a second. So it takes 1 second to recognize 4 images. Now, recognize 4 images per second is actually fairly fast. This is a CPU that's recognizing 4 images per second. It's incredibly fast by human times. But you know the internet is not human time. The internet is used by 2 billion users in China. And all of you, all of us, are asking questions of the internet at the same time. And so obviously, if a computer thinks at this level of performance, it is simply not enough. But before I show you, let's just hey Ryan, click at a few.
Sure.
Click at it. Let's see if these are right. Okay, so that one is a wallflower. Okay, that one's a toad lily. What's another one?
There's red ginger.
That's red ginger.
Trumpet creeper.
Click on a different square.
Sure.
That's love in the mist.
Yeah.
There's a flower called love in the mist.
I didn't know that.
Okay. That's a geranium. That's a lotus. Okay. I don't know that I would recognize that. Click another one. Morning glory. That's what morning glory looks like. That's beautiful. Canna lily. Okay. And so artificial intelligence. So far, I'm sure that this artificial network is better at recognizing flowers than every single human in this room. So artificial intelligence has achieved superhuman levels of image recognition. Let's see what happens now when we accelerate it with Tensor RT on V100. Ladies and gentlemen, save money. Save lots of money. This is the perfect example of the more GPUs you buy, the more money you will save. Okay, so just now you saw that the CPU was able to, on ResNet 152, classify 4 images per second. And now we're classifying 560 images per second. You see that right here? 560 images per second. Over 100 times speed up. Over 100 times speed up on ResNet 152. So it is not unexpected for us to see 100 times speed up in image recognition, in language translation, in voice recognition, and who knows what else. But the most amazing thing is this. This entire platform is programmable. This entire platform allows us to support every framework. This platform allows us to support any network. And those networks are inherently trained on the NVIDIA architecture, so it stands to reason it would inherently run great on NVIDIA's architecture. So amazing, amazing performance. I have another example to show you. This is speech recognition. This is speech recognition. This particular application, this neural network, is very unique. This is created by a company called DeepGram. DeepGram uses a speech recognition system that has a front end that's based on CNNs. The front end is based on CNN. And as a result, it's able to automatically detect, automatically extract the most important, the most relevant features in speech. Okay? It could able to detect automatically the most relevant features in speech. As a result, their performance, their quality of result is excellent. But because it was completely built on top of NVIDIA GPUs, its performance is also excellent. The DeepGram artificial intelligence network will be used by companies that can't go to the cloud. They could be hospitals. They could be financial services companies that take a lot of phone calls. And these companies would like to keep the voice data on-premise. And from that voice data, they could also use that voice data, which is now labeled, to, in addition, create other artificial intelligence services. But the thing that's really amazing is this. If the performance, if the accuracy and the performance of your neural network is high enough, you can actually do pretty amazing things. Now, in the United States, we watched this movie called Game of Thrones. Are you familiar with Game of Thrones? Okay. Yeah, Game of Thrones. It's dragons, kings, queens, magicians, craziness. Super popular movie. So Ryan, why don't you show us? Okay, and so this is a video. This is a video of the Game of Thrones. But this is the amazing thing. We now have a neural network that is so fast that you could just search whatever frame you want in the show. You know, instead of just scrolling looking for something, in the future you just say something and it would go exactly to that frame. Okay? Ryan's going to show it to you. Go ahead, Ryan.
Winter is coming.
So first, the DeepGram.
Winter is coming.
Oh, that's kind of unbelievable. That's kind of unbelievable. Oh, do another one.
No one will take my dragons.
No one will take my dragons.
No one will take my dragons.
Okay, well, do another one.
Your Grace.
It was well struck, Your Grace. Yes, Your Grace.
Your Grace.
These are, Your Grace.
Your Grace is used a lot in this show. Well, show me something else.
You know, here in China, check this one out. I've always wanted to see the Great Wall.
Night with your family. I've always wanted to see the wall.
What do you guys think? And so just think what it did. Just think what it did, okay? This video was ingested into our GPU. Of course, it has to be decoded. And as it decodes, the DeepGram neural network is converting every single voice, every single sound, and every single voice into text. And when we do a search, it literally runs through the entire video until it finds it. It does it so fast. It does voice to text so fast, we can now search on a full video. So, the NVIDIA Programmable Inference Acceleration Platform called Tensor RT, and it compiles and optimizes for all of NVIDIA's GPUs, and it understands the architecture of each GPU, and it understands the numerical precision capability of each GPU. Multiple frameworks, multiple architectures, multiple GPU architectures, and this optimizing compiler has to do all the magic in between using dynamic code optimization. The results, 100x throughput, twice the quality of service, incredible opportunities to save money. And this is an opportunity that at this time is particularly important. And the reason for that is this. The 2 billion users of the internet here in China is causing all of the internet service providers with all of their interesting services, whether it's photo sharing, live video, chat, news, all of these types of services today will be infused with AI so that they're more useful, so they're more delightful, they're more safe. We need AI in every single internet transaction, every single internet query, every single traffic that goes through the data center in the future will touch a neural net or many neural networks. And each one of these neural networks are highly computationally intensive. And so as the growth of deep learning is exploding, as you saw in the previous charts, data centers in the cloud will have to be re-engineered. We have to add inferencing accelerators to all of the nodes so that the throughput can continue to be sustained as the workload and AI workload increases. Otherwise, the number of data centers we have to build, the amount of land that's necessary, the amount of carbon footprint and electricity it will consume will just be off the charts. So, NVIDIA Tensor RT, programmable inference acceleration. I'm so delighted to announce today that all 5 of the leading internet AI companies in China has adopted NVIDIA's GPU inferencing platform. Alibaba Cloud, Tencent with WeChat, Baidu Cloud, JD.com, iFlyTech, every single one. Because all of them recognize the importance of deep learning. All of them have extraordinary artificial intelligence capabilities. And all of them want to put all these capabilities into the hands of the consumers to make your services better, more delightful. The internet services is where the first deployment and the first movement of artificial intelligence happened. And the reason for that is because the cloud service companies, the internet companies, have, number one, large amounts of data. They have a large amount of customers who benefit from artificial intelligence. They have massive data centers. And they have expertise in AI. These 3 characteristics, understanding the AI technology, having access to large number of customers so that you have data, and a computational infrastructure is vital to the advancement of AI. They were the first movers. However, there are many others that are quickly behind. One of the applications of inferencing, of artificial intelligence, that is massive in scale is our cities. In the future, all of our cities will be AIs. There will be AIs all over our cities. We need AIs all over our cities so that it's convenient. There's less traffic congestion. the resources of the city is diverted to where the workload is. There will be less power grid failures. The cities will be safer. You can find anything in the city. The cities will be massive AIs. One of the applications of an AI city is keeping its citizens safe, keeping people safe. In the near future, in just a few more years, there will be 1 billion cameras, 1 billion cameras in the world, high-definition video cameras, streaming live video all the time. Well, it's impossible to have people watch these videos. It is utterly impossible to have people monitor 1 billion video cameras. And that's just in the cities. And so the answer is clearly artificial intelligence. One of the leading companies in intelligent video is a company right here in China called Hikvision. Hikvision is the world's leading intelligent video company. And in fact, also one of the great leaders of artificial intelligence here in China. Several years ago, we started to work closely with Hikvision to realize this vision of a platform that is end-to-end created to enable cities to benefit from the power of artificial intelligence. From training the networks to creating new networks that could then be enjoyed and deployed at endpoints all over the world. And for these networks to be so intelligent, so robust, that we can find insight from the videos itself. Today, I'm delighted to announce that NVIDIA and Hikvision has created an end-to-end platform for inferencing, for AI cities, so that we could monitor and find insight in the 1 billion cameras that will be coming in the near future. Hikvision. It starts with a platform for learning, training the networks, which then produces an output that goes into Tensor RT, that creates an optimized framework, an optimized network that can run on whether a Tesla server or a Jetson server or a Jetson camera. Each one of them have different GPU architectures. Each one of them have different form factors, different power capability, different performance capability, and yet Tensor RT can produce the exact right network for each one of these platforms. It's then deployed all over the world, connected to cameras, and amazing insights could be discovered. Hikvision. The number of applications of smart cities and AI cities is really growing, and there's just countless. Hikvision is working on facial recognition, so if somebody were to be lost, very quickly these cameras would detect where that person is, identify exactly the location, and we can go find that person. In the case of Dahua, which is also another partner of ours, building an intelligent video platform based on the NVIDIA platform, essentially creates an artificial intelligence network that has essentially hundreds of virtual security guards. Watching very carefully a very important event, we essentially now have all of these virtual security guards. In the case of Huawei, these traffic monitors helps us detect where the traffic jams are and where the peak traffics are. In the case of Alibaba, monitoring all of the traffic, determining where is congestion, and redirecting traffic accordingly. And so whether it's improving the flow of traffic through a city, finding a lost one, a loved one, or keeping society safe, intelligent video, artificial intelligence is going to revolutionize how cities are built in the future. We call it AI City. However, the number of applications is daunting. There are so many great ideas. We're working with hundreds of companies, big and small, in the area of video analytics. Video analytics comes in all kinds of sizes and shapes, and it's impossible to create one single network that allows us to infer insight in all kinds of conditions, on the one hand. On the other hand, all of these companies cannot afford to invest in a very high quality CNN core, a code base, an original network that is incredibly high performance, incredibly high quality. And so we found a solution for that, and we created a flow that allows all of our customers to adapt a starting neural network for their applications. And so let me give you some examples. On the left here are some examples of our neural network being used in, the core network being used in several different use cases. So for example, in the first place, maybe the angle of the camera, the vantage point of the camera, is different than the originally trained network. This camera is now placed 20 feet up. And so as you could see, there are some areas of detection that it didn't do a very good job. Another example, maybe it's an indoor camera designed specifically for indoors, and you could see also our network, the original network, didn't do a very good job. Or maybe it's a 360-degree camera, and its ability to detect each one of the cars and the license plates was limited. And so the workflow that we created was this. We start with a pre-trained network. It comes in the store that our application for deep learning adaptation, neural net adaptation, we call Digits, that runs on our DGX station or any of the NVIDIA GPUs. Okay? Digits is a neural network adaptation software. DGX station is a GPU computing platform. You could take the originally pre-trained network, add additional images of your use case to now adapt the network to a new network. The new network then runs through Tensor RT to optimize it for the computing platform that you intend to run it on. And you can see the results are just fantastic. You start out with an original core that is very, very high quality. You could train it some more. In deep learning, it's called transfer learning. We can apply transfer learning to adapt that network for your particular use case, and the results are fantastic. Okay, so irrespective now of the use cases that you imagine, we can start with a pre-trained network core, our adaptation workflow, and with Tensor RT, you could apply it to whatever computing device makes the most sense for you, for your performance, for your form factor, for your cost level, whatever the requirements are, there's a solution for you. Okay, so ladies and gentlemen, NVIDIA's programmable inference acceleration platform built around a new optimizing compiler called Tensor RT. Artificial intelligence has revolutionized internet services. It's going to revolutionize our cities. As you know, one of the areas of great investment of our company is transportation. This is one of the world's largest industries. This is one of the world's largest industries. Whether the size of the industry itself, the benefit that it brings to society to give us freedom, the cost of provisioning this capability of mobility, whether it's in city roads or the carbon footprint that it takes up, the parking lots that we create for these cars, all the trucks that moves the atoms all over society for us, or the accidents that occur as a result of the visits to the emergency room, the ambulances, the insurance companies that we have to take insurance from. In every aspect of our lives, from all the benefits of transportation, the infrastructural needs and capabilities provided by transportation, and all of the indirect cost that we incur as a result of the benefits of transportation, all of it combined is one of the great social challenges of our time. And one of the things that's really exciting, and the reason why we decided to dedicate enormous amount of engineering into autonomous vehicles starting 5 years ago, is because of the benefits that we believe AI will bring to this one very important aspect of living. This is, in the next year or two, going to be the beginning of a revolution like you've not seen. Now, the long-term trajectory of autonomous vehicles is also super exciting because of two fundamental technologies, electrification and autonomous capability as a result of AI. These two technologies, these two advances, is going to make it possible for us to even redefine and reimagine the shape of cars. This is a project. What you're looking at here is a real project. It is a real project that we're working on with Airbus. What you're seeing is three pieces. It's a car with three separable pieces. The first piece on the bottom is the drivetrain. It's the electrical drivetrain. And because it's electric, it's easy to detach. It's easy to detach the cabin from the drivetrain. The second is a cockpit, a cabin with no steering wheels. It is completely autonomous. And the third is a wing, a flying wing that is autonomous, self-flying drone that is electric-powered. Electric-powered wing, autonomous computer cabin, and an electric chassis. If we could make these two technologies possible, in the future, you would simply press a button on the phone. Your autonomous car will come and pick you up in your driveway. You will drive to wherever you park. You would say you would like to go to the other side of Beijing without suffering the traffic. A wing will come automatically and find you, pick you up, and take you to the other side of Beijing. You could jump through all of those circles. Incredible. Incredible. The future of autonomous vehicles is both exciting as well as beneficial to society. And so our vision is this. We created a computing platform from the ground up, a computing platform from the ground up. The computing platform itself we call Drive PX, an ASIL-D, functional, safe, fail-operate operating system called Drive OS, a state-of-the-art SDK with deep learning, all of the technology you've seen so far and all of our inferencing capability inside it, state-of-the-art computer vision algorithms, supporting all kinds of sensors from radar to camera to LiDAR. Stacked on top of that, a self-driving autonomous vehicle stack that allows us to drive a car from end to end. We have thousands of engineers at NVIDIA working on this. We have a great partner here in China already, Alibaba, who is open sourcing their software, but on top of the NVIDIA stack. This computing platform will allow us to achieve level 3 to level 5. Level 3 is sometimes the car drives by itself, and when it's driving by itself, you're completely safe, and the car company is completely liable for the performance of the car. This is a very big deal. Level 3 is a gigantic step for the autonomous vehicle industry. A gigantic step, because the car companies are liable. And level 4, the car will be autonomous much of the time, and when it's autonomous, the car is completely trustworthy and liable. And then level 5, there's no driver in the car at all. And if anything were to happen to the sensors, the computer, or the algorithm, there will be a backup, a redundancy that is diverse enough to complete its mission. Because otherwise, you would have to tell your passengers to get out. And so that's obviously unacceptable. Level 5 robot taxi capability is driverless. all of these levels, level 3, level 4, level 5, is a gigantic step for the automotive industry. Let me show you some of our work in progress. The video I'm going to show you is a bunch of engineering clips. And it's engineering clips that walks past perception, localization, and planning, the 3 fundamental tasks of an autonomous machine. Perceive the environment using all the sensors available, radar, camera, LiDAR. Perceive the environment. Reason about where you are, localization, and where everything else is, localization. And then lastly, to plan your driving actions. How do you steer? How do you apply brakes? How do you accelerate? Okay? Perception, reasoning or localization in the case of a car, and planning are the 3 fundamental tasks of an autonomous machine, of which, by the way, we are one. Humans perceive the environment, reason about the context, and decide what actions to take, planning. Okay? The 3 fundamental tasks of autonomous machines. And so let me show you some videos of our engineering work as we stitched it together here for you to see. You can see that the car is being detected in 3D. Each one of the segments of the blue bounding box, the green, and the red tells us the 3-dimensional structure of the car. We're detecting here the distance completely from deep learning. You look at the image and the velocity of all of the objects around you, and you can detect how far away the objects are. This is free space detection, where your car is allowed to drive. This is free space using LiDAR. Ego motion, which is what is the motion and the trajectory of yourself, ego. Using LiDAR. We localize to an HD map using computer vision alone. We localize to an HD map using LiDAR information so that we have 2 different approaches to give us diversity and redundancy. Path planning using computation. The parallel computing capability of our GPU, CUDA, allows us to try every single path at the same time. And this is using artificial intelligence to see how we should drive. And this car is now going to take a turn all by itself. All completely based on deep learning. Okay, guys. The NVIDIA Drive platform is an open platform. Our partners could intersect the Drive platform at every single level, all the way down to Drive OS, on top on top using our SDKs and DriveWorks, or using some or all of our Drive AV algorithms. Now, the reason why it's so important that we also do it, along with all of the companies out in the world, is because it turns out, in order to achieve level 5 and level 4, we have to have redundancy and diversity. Redundancy and diversity. It is now possible for us. It is now possible for us because we created one stack completely from scratch. We could mix and match with all of our partners around the world so that we can deliver a car that has redundancy and diversity in its driving stack in the car. And as a result, functional failure can be assured. Functional safety and fail functional can be assured. Our platform is used by companies all over the world. Just startups alone, there are 145 autonomous vehicle startups in trucking, shuttles, mapping, logistics planning, taxis. Unbelievable investments are being made in this field. And the reason for that is very simple. The impact to society is great. The technology necessary to achieve autonomous levels are now finally here. The problem is incredibly challenging. And so it can sustain innovation of these startups for a long time and sustain differentiation. And most importantly, the industry is utterly massive. There are 145 AV startups. Here in China, Cognata is working on a deep learning autonomous simulation tool. DeepMap is a HD mapping platform for very, very large scale. Momenta is working on a driving brain, a brain for self-driving for autonomous vehicles. Navia is working on the last mile. This is a shuttle, an infrastructure play. The shuttle as well as the service for the last mile. Imagine in the future, more and more home deliveries will happen. It delivers to a hub, and that last mile is delivered with something like Navia. We have TuSimple, which is solving one of the great opportunities and great problems in society, which is the amount of trucks, drivers that's needed. It turns out we have a severe shortage of truck drivers in the world. And the reason for that is because all of us are buying products on Alibaba. All of us are buying products on JD.com. We used to drive to the store. Now the store has to drive to us. And there are billions of consumers around the world that has to do this. As a result, the number of goods, the goods that has to come to warehouses, moved around all over the world is really intensified. TuSimple is going to make it possible for these trucks, for truck drivers to be more relaxed, to take the pressure off of driving, or to extend their range. And then Zoox is working from the ground up, powered by NVIDIA Drive, working on a ground up, a brand new taxi. The architecture is brand new. The architecture of this taxi is brand new, and they'll create the taxi as well as the services that go with it. 145 AV startups built on top of the NVIDIA Drive platform. Thank you very much. We chose self-driving cars, autonomous vehicles, as our first endeavor of autonomous machines. Surprisingly, because it's easiest. Surprisingly, because it's easiest. It turns out that autonomous vehicles, as great of a challenge as it is, as amazing of an impact to society as it is the easiest of all the autonomous machines to do. And the reason for that is because its fundamental purpose is collision avoidance. We could teach this autonomous machine not to interact. Its purpose is please do not interact with the environment. Stay away from the environment, stay within the lanes, follow the rules. So autonomous vehicles, as it turns out, is the easiest of all the autonomous machine problems to solve. However, it has tremendous opportunity to enhance society. We think that the pieces of technology for the next era of AI is coming together. The next era of AI will combine several important technologies. Sensor revolution, and the number of sensors and the cost of sensors and the dynamic range and the capability of sensors are improving all the time. Number two, the artificial intelligence networks are advancing at incredible rates. And then number three, of course, electric motors. These pieces of technology have made it possible for us to finally imagine the next phase. And we think the next era of artificial intelligence is the era of autonomous machines, where AI leaves the cloud. Where AI leaves the cloud, it enters into a machine that interacts with us and helps us perform tasks that we can't do ourselves. Autonomous machines. Really, really exciting future. There are two fundamental things that are missing. AI, of course, is going to continue to advance. You saw reinforcement learning approach where Peter Beal at University of Berkeley was able to go into virtual reality and demonstrate to the robot just a few times how to stack a bunch of bricks, And once it was shown, demonstrated just a few times, the robot using reinforcement learning and a approach called meta-learning has the ability to pick up the new examples, generalize the knowledge, and now apply that task to a whole lot of different circumstances. So reinforcement learning, meta-learning, one-shot learning, imitation learning, all of that based on deep learning is advancing so fast that we believe the AI will get there. There are two fundamental pieces of technology that's missing. The first is a processor. This computer is radically different. The processor for autonomous machines is fundamentally different than the processor for a cell phone. It stands to reason that the computer of an autonomous machine, the processor of an autonomous machine, is fundamentally different than the processor of a laptop. The autonomous machine has sensors that are rich and high definition and very, very high bit rate, and it's streaming in at real time and all the time. The second thing is it has to infer, it has to perceive the environment around it to reconstruct what is happening in the world around it, using deep learning, using computer vision, using sensor fusion of all kinds. The third, it has to do parallel computing algorithms, perform parallel computing algorithms to reason about what is happening around the world around it, and then finally to plan and take action. This processor has never been built before. Several years ago, we dedicated ourselves to build the world's first autonomous machine processor to get ready for today. We call that processor Project Xavier. Project Xavier. It is a supercomputer on a chip. It is the work of several hundred NVIDIA engineers. It is one of the most complex projects that we have ever done. It is unquestionably the most complex SoC the world has ever created. It is extremely energy efficient because you want it to be autonomous and battery life matters, and it's performing a lot of tasks. It supports rich IOs and sensors, and it has essentially a supercomputer on this chip. 30 tops of processing, all in real time. Xavier will be sampled to our early development partners in Q1 of next year, basically in a few more months. It is design complete, and we're in the process of producing it. The second wave of partners will see it probably in about Q3 or Q4 of next year. Okay, so for our early development partners, we'll start sampling to them in Q1. Autonomous machines is the investment in the project of some of the world's largest and greatest companies. They recognize that there are unsolvable problems in society, in the world, unless we bring artificial intelligence out of the cloud. One of those great companies is a partner of ours that's working on a large suite of robotics technology. Ladies and gentlemen, JDX has selected NVIDIA for autonomous machines. There are 30 billion parcels that are being handled every single day around the world. 30 billion. There's a few million forklifts handling all of these warehouses. These machines will become autonomous. JDX is also building a robot that will deliver groceries, your dinner, soy sauce to your house. And they could reduce the cost of delivery tremendously. And they're building autonomous drones that also can deliver products. I'm very excited to welcome JDX, and it's great to have the partnership in inventing the future of autonomous machines. The second piece of technology that is necessary is a virtual reality simulator. Let me tell you why. The middle is how we imagine deep learning today. We use a GPU computing platform CUDA with all the frameworks that it accelerates, and we create a neural network. That neural network could be applied to a robot that has an autonomous machine processor called Xavier. That was the first piece. This piece already exists, and we'll continue to advance it, and new algorithms will continue to emerge. And this processor, we're just building it. And so you could imagine these two pieces. But as it turns out, that's not enough. And the reason for that is because in order for us to teach these robots how to behave, and because robots interact with the world, it can break the world, it can harm the world while it's learning. And so we have to create a virtual world. We have to create a photorealistic virtual world where robots can grow up to be good robots, where robots can learn how to be robotic, where robots can learn autonomous tasks, and where we can go into these virtual reality environments and we can teach it. This virtual reality simulator has to be photorealistic. It has to obey the laws of physics. It has to process artificial intelligence networks. And it also has to be able to do it in super real time. And the reason for that is because we don't want to wait to train these robots over the course of years. We want to train these robots over the course of minutes, hours, and days. And so we created a brand new, the most advanced virtual reality environment the world's ever seen. We call it Project Isaac. Isaac is named after Isaac Newton and Isaac Asimov. And Isaac has a lab, and this lab is in virtual reality. Let me show it to you now. So what you're seeing here is Isaac's lab. And in this particular case, Isaac's lab is a hockey rink. And we're letting Isaac learn how to play hockey. Now, in the beginning, it takes some time. We don't have time to show it to you here. But in the beginning, Isaac has to figure out even how to pick up the puck, pick up the stick. And what's the best way to hold the stick? It uses its eyes. You could see the eyes of Isaac. It's looking. The eyes have CNN, and it's using deep learning to recognize the rink. And it tries over and over and over again until it becomes good at playing hockey. And it uses a technology, uses a network called reinforcement learning, and every time it sinks the puck, it gets rewarded, and every time it doesn't, it gets a punishment. Of course, the punishment is just math. It's not really punishment. And as a result, Isaac can learn how to play hockey. We could teach Isaac almost anything. We could teach Isaac how to play golf. Jeffrey, let's go to golf. This is Isaac learning how to play golf. It sees the green. Right now, we're teaching Isaac how to read the green. We're not quite ready yet, but we're teaching Isaac how to read the terrain of the green using its eyes. And it has to figure out the thickness of the grass, the velocity of the ball, and how hard to hit it, depending on its distance. Okay, how about one more time? Oh, that's easy. Those are easy. Let's go far out. Let's take Isaac a little further out, and let's see if we could do it. Grandmaster, right here. You could do it. Come on, let's cheer Isaac on. You could do it. Isaac. A little air. Ladies and gentlemen, autonomous machines enabled by artificial intelligence, reinforcement learning with a robot that learned in a virtual reality environment. The future of autonomous machines. And so, as you could see, we have all three pieces necessary to revolutionize this new field. We have deep learning and all of the capabilities around it, a computing platform that allows us to create these networks and train these networks super fast. We have a processor that is designed for autonomous machines. And now we have an environment, a virtual world by which robots can learn to be robots. Okay? So all three pieces of the technology necessary, we believe, to lay the foundation for the next era of AI has been put in place. We talked about a lot of stuff today. It's great to welcome all of you to this year's GTC. This is truly a new computing era. We talked about 5 things today. The first is the world's AI computing platform. Our vision is to enable every researcher everywhere to advance AI for the goodness of mankind. We've taken our platform and we've advanced it at the speed of light. We've taken our platform and with the support of all of our partners, adopted it into clouds, into data centers, into products that can be enjoyed by everyone. The second, we talked about NVIDIA Tensor RT, the world's first programmable inference acceleration platform. The reason why it's so difficult is because there are so many different frameworks. It's creating so many different architectures of networks, and these networks are getting more and more complex. And the target device is ranging from supercomputers, to hyperscale data centers, all the way down to cars and robots. The target, the frameworks, the networks, the complexity is all exploding at the same time. And so we created an optimizing compiler that could take all of this and create incredibly optimized code. The results are 40, 100, 140 times improvement in throughput. And as a result of that, you could scale out to support the explosive number of workloads that are coming into the data centers while saving money at the same time. Saving money. One of the great challenges and one of the great opportunities to apply AI to our cities for our convenience, for more efficiency, for our safety. However, there are 1 billion cameras, and it's impossible to monitor all of them. If we were to monitor every single one of those cameras, and we run all of that live video into our highest performance GPU, Tesla V100, it would take 10 million Tesla V100s to inference all of the 1 billion live cameras. This is a gigantic market challenge. It's a gigantic market opportunity. We have great partners in Alibaba, Dahua, Hikvision, Huawei. The NVIDIA Drive platform. One of my passions to revolutionize the transportation industry. One of the largest industries in the world, but its adjacent impact on society, whether the design of urban environments or hospitals and insurance and the cost of lives, all of the peripheral implications to society is great. We believe that by creating a platform we call the NVIDIA Drive and making it available to all of the amazing companies in the world, whether they're established car companies, taxi service companies, ride-sharing companies, logistics companies like DHL, one of the world's largest, or the 145 startups that are dedicating their lives to revolutionizing this industry with us. We created a platform that is wide open for the world to innovate around. And then lastly, the next era of artificial intelligence, where the artificial intelligence will come out of the cloud and will be inside these autonomous machines. The processor has to be completely reinvented. We call that processor Xavier. And the infrastructure and the platforms necessary to create these robots has to be created. We call that Project Isaac. We believe we now have the fundamental pillars in place to invent the next era of artificial intelligence, autonomous machines. Ladies and gentlemen, thank you for joining GTC. Let's go create the future together. Thank you.